Number 6, suppose the sine of theta is 8 over 17 in quadrant 1. Find the cosine of theta. So we know that we are in quadrant 1. So we know we have a triangle right here in quadrant 1. Now when you look at sine, we know that sine is the y value when you're in the unit circle, but remember when we're out of the unit circle, it's y over r. So sine is y over r, which means the 8 is the y and the 17 is the r value. So I'm going to go ahead and label my triangle. My y value is 8, 17 is the r. I still need to find side x. So to find the cosine, I would need to find x over r. So we need to solve for what x is. So I'm going to do the Pythagorean theorem, x squared plus y squared equals r squared, and plug in my values. So y is 8 squared and r is 17. So if I do 17 squared, I get 289. 8 squared is 64. So subtract 64 from both sides and you end up with 225. And then you're going to take the square root of 225. And remember, when you take the square root of both sides, it's always a plus or a minus. So the square root of 225 is 15. So my answer is either a positive or a negative 15. So when I look back at my picture, I see that x is going to quadrant 1. It's going to the right, which means I would use the positive value, not the negative value. So just as a reminder, if I was over here in quadrant 2 and I did this Pythagorean theorem, if this was 8, this was 17, this would be a negative 15 because I'm going towards the left, okay? So we're not in quadrant 2, I don't have to worry about that right now, but for future problems, keep that in mind. So whichever direction on your triangle you're moving, use that sign. So x is a positive 15. So x is positive 15, y is a positive 8, and r, we decided, was 17. So to find the cosine of theta, I do x over r. So the x coordinate was 15, and the r coordinate was 17. So our ending answer should be 15 over 17.